Okay, I think we probably can get started. So I wanted to welcome you all this informational webinar of our Biomedical Engineering graduate program at Institut Polytechnique de Paris, or IP Paris. So just to tell you a little bit about us. So these are your BME program contacts. I'm Abdul Barakat. I'm a professor at Ecole Polytechnique, and I am the Biomedical Engineering Academic Advisor. We also have with us Professor Nesma Houmani, who is the track advisor for the Biomedical Data Science track, and we'll talk a lot more about that in a few minutes. Silvia Corsini is also here. Silvia Corsini is our program manager. And then Nabila Sadli is also with us. She's the project manager for the Biomedical Data Science track. Other people who are not here today, but who you would interact with quite a bit if you were to come here, which we hope you will, of course, is Angelique Gracia, who is our master's program coordinator, and Joni Frederick, who is our biomedical engineering facilities manager. So we are all happy that you were able to join us today, and we hope that that you'll find this webinar informational. What we'll do here is we'll present for about 30 minutes or so, and then after that we'll open it up for your questions to or if you need any additional information or if you need any points clarified. Okay, time to brag a little bit. So IP Paris, or Institut Polytechnique de Paris, is a fairly young institution. It was actually established in 2019, but it was established based on 6 very well-established engineering schools in France. And as you can see from this national ranking, actually it's a combination of several rankings, the IP Paris engineering schools are basically among the top engineering schools in France. So we think that IP Paris is basically the top engineering program in France. This is at the national level, but also at the international level. IP Paris is quite well recognized and highly considered. So, for example, in the US World University Rankings, we're 38th worldwide in engineering and technology, and 10th worldwide in employer reputation. In the CWR rankings, we're 30th worldwide in the physical sciences. In the Times Higher Education ranking, we're 71st worldwide among more than 1,600 institutions. In the Shanghai Global Rankings, we're in the top 40 and top 50 in physics and math. So you can see we're one of the top science and engineering universities worldwide. And what that, of course, means to you is if you were to come here, that would open up a lot of doors for you. It would provide you with a lot of opportunities to do cutting-edge research, to participate in a lot of world-class activities, to really be at the cutting edge of science and technology. And of course, what that means also is if you were to come here, we would expect you to work hard and to uphold the reputation that we've built. So, it's a two-way deal here. We promise to provide you the opportunities and the resources, and hopefully you'll be able to work hard and realize your desires and professional ambitions here. So let's talk a little bit more about the biomedical engineering graduate program more specifically. So ours is a fairly young program. We're in the 7th year of this program. But importantly, this is going to be the first year where this program is its own degree granting program. So up until this academic year, the biomedical engineering program was actually housed in the mechanics department. But last year, we actually asked for independent biomedical engineering accreditation, and that was granted to us this year. So starting this coming academic year, we will have our own biomedical engineering degree granting program. And that's very important, actually, because some students who who come from backgrounds other than mechanics or mechanical engineering, for example, computer science or physics or applied math, may not necessarily want degrees in mechanics, right? So the fact that we have now a biomedical engineering degree granting program allows these students to get the degree that they always wanted by applying to this program, and that's a biomedical engineering degree. So when you apply to our program, you can actually apply either the PhD track or the master's program. And the PhD track that biomedical engineering is part of, is called Bioengineering and Quantitative Life Sciences. And the PhD track program is basically an integrated master's and PhD program. So this is kind of a very highly selective admissions program. It is reserved to top applicants, but it allows them to basically directly go into an integrated master's and PhD program. And it allows them, more one-on-one advising. It allows them things like, an individual tutor, early research opportunities, and things of that nature. We'll talk about funding a little bit later. You could also apply to the master's program, which is which would be the biomedical engineering master's program. And historically, about 70% of our master's students opt to go on and pursue PhDs. So if you start with a master's program, then you can, of course, continue on for the PhD following completion of the master's. Now, the master's program is a two-year master's program. So the first year is what we call the M1 year, and the second year is what we call the M2. And typically, you would apply if you're coming with a bachelor's degree in mechanical engineering, biomedical engineering, other types of engineering or physics, you would typically apply at the M1 level, so the first year master's level. There are a few exceptions. If you, for example, if you already have a master's degree, you can directly apply at the M2 level. Also, if you've done an engineering school in France, where after high school you've done the prépa, the 2 years of prep classes before starting at the engineering school, so you will have done 5 years in total, with the third year of your engineering school counting as the M1, then you can also apply for the M2 level. But in the vast majority of the cases, the students would actually apply at the M1 level, the master's students. Ours is a highly selective program, so we get a lot more applicants that we're able to admit. It's a research-oriented program, and that's important because part of the fact that we are a top-ranked institution is based on our research reputation. So we aim to attract students who are interested in research. It's a highly interdisciplinary program. So as you'll see when I talk about the courses, basically, we'll do physics, and we'll do mechanics, and we'll do informatics, and we'll do computer science, and we'll do some biology. So it's an interdisciplinary approach. And then the students we recruit are basically physics and engineering students rather than biology students. So I know there are some biomedical engineering programs around the world that admit students who come from the biological sciences. We have opted to not do so because a lot of our courses tend to be pretty physics and mathematics and engineering oriented. So the students we recruit are typically physics and engineering students. Okay, just to kind of make sure that everybody's clear on what we mean by biomedical engineering. I mean, some of you have biomedical engineering degrees or are getting them, but some of you come from different backgrounds. So biomedical engineering is basically the application of physical science and engineering to understanding, diagnosing, and treating disease. And biomedical engineering as an academic endeavor has a number of subfields, including biophysics and biomechanics, imaging, devices, biomaterials, bioinformatics, data science applied to health. So as you can see, it's a vast field, and it's a field that where you really can potentially make a concrete difference in health and in people's well-being. And this is something that I think a lot of us who work in this field, that's why we're attracted to it, because we believe we can actually make a difference in society and people's well-being by pursuing research, innovation, and teaching in the field of biomedical engineering. So, of course, we do all of this in order to serve humanity in different ways. For example, in developing novel medical devices, or working on tissue engineering and regenerative medicine, or developing new novel imaging modalities and sequences and image analysis schemes, or developing new drug delivery systems or various connected health products, etc. So the applications are quite vast. If you're applying to this program, you're probably very aware that today's medicine is actually undergoing a revolution, and that revolution is being catalyzed by a number of very important technologies that are all coming together at the same time to allow us to do many things that we couldn't dream of before. So when you start thinking about the convergence of flexible electronics with AI, with bioprinting, with connected devices, nanoscience and nanotechnology, and very fast computing, you can dream up a lot of opportunities for coming up with a lot of really novel applications to medicine. And the medical community, medical doctors, are becoming increasingly aware of this, and they're definitely very open and receptive to the idea of engineers contributing to to medical practice and coming up with kind of novel approaches to medicine. But what this is actually allowing is that medicine, it's allowing for medicine to become highly personalized, right? You hear a lot about personalized medicine today, as opposed to the one-size-fits-all approach that we always in the past used to pursue. You also hear a lot about targeted medicine. For example, in cancer, a lot of traditional therapies are not very targeted. Radiation therapy, chemotherapy, damage normal cells as well as cancer cells. So there's a lot of interest in trying to target only disease locations and not healthy locations, right? Medicine's becoming a lot more connected, right? Because a lot of these devices now give you information about, in real time and continuously, about the status of people's health. And medicine is becoming very patient-driven in the sense that patients today have a lot more information, and when they go to see their doctors, they tend to go in with a lot of, they have a lot of resources to get information about their symptoms, and say they go in expecting to get a lot more detail and a lot more personalized advice as to their health situation. But what that also means is we need to train you guys. We need to train today's and tomorrow's engineers appropriately to make sure that they're able to fully leverage their knowledge in this revolution in medicine and be leaders and major players in the development of this revolution in medicine. And that's kind of the driving force behind our program. Okay, let's talk a little bit about courses, because I know this would be something that you would be interested in hearing about. So you can think of the BME graduate program in a way as a 5-year master's PhD program, right? That's how I'm going to present it. So the first 2 years are basically the master's phase, and then the last 3 years are the PhD phase. So we'll start by talking about the courses in year one. So in year one, which is the M1 year, the M1 year is basically an opportunity to have core course training that would be common to all students. So we have students coming from different backgrounds, some from mechanics or mechanical engineering, some from electrical engineering, some from physics, some from applied math, some from computer science. And now we need kind of common language, right? So we've come up with 10 courses in year one that we think are important as common core course training. So our academic year has two academic quarters, the fall quarter and the winter quarter. There's also a spring quarter, but for this purpose, we're going to talk about the fall quarter, which runs from September to December. And in the fall quarter of the M1 year, you would take these 5 classes shown here. So a basic course in cell biology and physiology for engineers. So some of you may not have held any biology or physiology before, and that's perfectly fine. We don't have a biology prerequisite for admission. So we try to give you whatever cell biology and physiology you need, at least the basic in the first class. And then if you need more, of course, you can take more advanced classes, and you can pick up a lot of biology also in research settings. Statistics and data analysis is going to be important for no matter what you end up doing. So we think it's very important for you to have a basic course in statistics and data analysis as part of your initial training. Machine learning, again, this is the fundamentals and applications of machine learning. So this is kind of an introductory course to machine learning. But as you all know, and AI and machine learning in general is going to be, or is already involved in a lot of engineering practice, and it's going to be more and more so. So it's very important for you guys to get some training in that area. Signal and image processing, again, regardless of what you end up doing in biomedical engineering, you'll probably be acquiring signals, you'll probably be acquiring images. It's important to know how to process, how to treat, how to handle signals and images. And then, because we're a research-oriented program, we want to get you kind of thinking about research early, and that can happen through these research topics, which can take the format of a journal club or some grant writing exercises and things of that nature. In the winter quarter, which runs from January to March, we have a course that's called Innovation in Hospitals, where you basically will spend time at one of our partner hospitals, and there you will interact quite a bit with medical doctors. And the goal there is to come up with innovative solutions to problems that medical doctors currently have. So, the medical doctors will tell you about their specialties, and then they'll also tell you about some issues or limitations or problems that they may have. And they would expect you then, working in groups, to come up with innovative solutions to some of those problems. And so that's what this course is about. And the students typically like this course quite a bit, because it gives them a very kind of concrete and very direct interaction with the medical community. Mathematical modeling of biological systems, that's something that we think is very important as well. So a lot of you, as you progress in your studies and as you move on and do some research, will probably be doing some modeling. Some of you will be doing experiments, some of you will exclusively, some will be doing modeling exclusively, some will be combining experiments and modeling, but modeling is a very powerful tool in biomedical engineering. So we think giving you the basics of mathematical modeling of biological systems is a very important skill for you to acquire. Ethics is a very important area in biomedical engineering. So you'll have a course in biomedical ethics. There is a mounting interest in the field of digital twins for biomedical applications. And so this is a new class that we're going to be introducing in biomedical engineering, digital twins. And then the last course is a free elective that you can basically choose to take out of a wide list of classes. So these are the 10 core classes that you will take in the fall and the winter quarters of your first year. Now, in the third quarter, which is April to June, you will do 2 one-month lab rotations, and these are intended to basically give you initiation to research. So you'll spend some time in 2 different laboratories on campus, where you will typically get involved in a research project, maybe analyzing some data, maybe kind of working with a PhD student or working with a postdoc in the lab, where you'd have your own small project, because in 1 month you can't do a whole lot, but small, maybe data analysis or a small experiment or small analysis of some sort. where the intent is to basically give you an experience as to how research labs run, and to have you see at least 2 different labs so you can start getting an idea of what labs you may want to join later as you get more and more into research. And then throughout the first year, we have a year-long design project that you'll work on in groups. So these are projects that we get either from hospitals or from research labs or from companies, where and some of the companies could be big companies or some startup companies, and they all basically propose various projects, and then we would present to you these projects, and you'll form groups and you'll work on these projects year long. And the idea is to start, during the fall, kind of defining the problem, defining the objectives, and then as the year progresses, you'll start formulating things, building a prototype, testing it, iterating, and then until you finally converge onto a design that works. So that's year one. Now the M2 year, or the year 2, is a specialization year, and for that we basically have 4. You will pick your major, and there'll be one other track that you'll pick as your minor. So the 4 tracks are shown here. The first is imaging and image-based modeling. The second is biomechanics and biophysics. The third is biomaterials and biodevices. And the fourth is biomedical data science and applications. So you'll pick one of these tracks as your major and another one as your minor. And when you do that, that basically says that you take 6 courses in the track that you pick as your major, 3 courses in the track that you pick as your minor. That will be 9 courses. And then you'll need to take a 10th course, which is a free elective from, again, a list of courses that we would provide. So all that happens between these 10 courses, so 5 typically in the fall, 5 in the winter, and then at the end of March, that's when the courses end, and then the period of April to August of your M2 year is basically a research internship or a master's thesis, typically that lasts 5 to 6 months. So that is basically a thesis or an internship where you really get involved in research, and in the following September, you defend that thesis in front of a committee of faculty members in our program. Okay, now let's talk a little bit about the specific courses in each of the tracks, the 4 tracks that I mentioned. So imaging and image-based modeling, these are the 6 required courses if you were to pick this track as your major, right? So there are 2 courses in the fall, 4 courses in the winter. You can see there's advanced machine learning, optical imaging, there's advanced microscopy, where you talk about the physics of microscopy, different types of microscopy, electron microscopy, wide field microscopy, light sheet microscopy, confocal microscopy, different types of techniques, biophotonics and applications, and then a data science course applied specifically to medical imaging, and a course in computer vision and applied to medical imaging again. So these would be the 6 courses you would take if you had imaging and image-based modeling as your major. If imaging and image-based modeling is your minor, you would take 3. You would choose 3 out of these 6 courses as your minor. For the biomechanics and biophysics track, these are the courses, the 6 required courses. So 3 in the fall, 3 in the winter, 1 in biofluids, 1 in biosolids, 1 in microfluidics, 1 in cellular mechanics, 1 is a project class in biomechanics, where you do some work on research projects, and 1 specifically focuses on the physics and mechanics of motility, because motility is something that happens at all scales, right? Motility happens at the molecular scale, at the cellular scale, at the organismal scale, at the organ scale. So motility is kind of an omnipresent topic in biomechanics. So understanding the physics and mechanics and motility is important. The third track is the biomaterials and biodevices track. So here are the 6 required courses: a course in wearable devices and communication systems, a course in introduction to biomaterials, a course in advanced materials design, a course in surface bioengineering, a course in kind of advanced topics in material science, and a course in materials modeling at different scales, from the atomistic scale to the macroscopic scale. I will now let Professor Nesma Houmani talk specifically about the biomedical data science and applications track.
Yeah, so thank you, Abdul. Yeah, so the fourth track, biomedical data science and applications. So it is constructed around the data chain value from its acquisition to its processing and analysis, including its preparation, its pre-processing, the workflow management, also including ethics, regulations, and also, of course, machine learning, AI-based approaches. You have here in the first, so from September to December, you have data sources and collection, for example, which is focusing on the acquisition of the data. The data can be images or behavior data or electrophysiological data. Data preparation and workflow management. This course is dedicated to all the pre-processing tools in order to prepare the data before the application of machine learning. You have also another course, study design of AI and innovation. There we have many conferences which are given by different experts from industry and also from the clinical environment, who are presenting the current projects on AI and how we can apply this AI for real problematics. And then in the winter quarter, you have courses which are more focusing on AI techniques, machine learning techniques, including deep learning, graph-oriented approaches, and advanced machine learning. And so the majority of the sessions are include practice, because we think that this is important for you to be familiar with AI tools and computer science, how you can use these tools in order to solve, to work on real data and also to analyze this data. So the practice is important, and also to learn how to put theory into practice. So this is important. So this is yeah, the structure of this track.
Thank you very much, Nesma. And Professor Houmani will be here until the end, so if you have questions about this specific track, you'll certainly be able to ask them at the end of the presentation.
Yeah, of course.
So we talked so far about the first 2 years, the master's phase, and then of course comes the PhD phase, which is years 3 to 5. So typically in France, a PhD takes 3 years nominally. Sometimes it may take a little bit longer, but nominally it's 3 years. So basically there you do a research, a thesis, right? A PhD thesis. One interesting thing about our program is we actually have funding to send students who may be interested in an international experience to spend a few months abroad during their PhD. Also, all of our students at conferences, workshops, symposia, either nationally or internationally. So you'll have plenty of opportunities to present your results and your work in all sorts of settings. A few additional features in our biomedical engineering program that you would be able to benefit from if you were to come here is we have a regular seminar series. So both our faculty and alumni from our program. These seminars, basically the faculty talk about their research, and that way you're familiar with what labs are doing what. And then the alumni are former graduates from our program who come back and share their experiences either in academia or in industry with the students. And it helps you basically see what possible things you can do after graduating from our program. We also have an annual symposium, an annual research symposium that you would certainly be you would participate in, and that's a chance to kind of get a feel for all the ongoing research activities on campus. We do periodic biomedical engineering advising sessions, and we organize various visits to laboratories, to hospitals, to various companies. So these are things that we kind of schedule throughout the year. We also have regular calls for funds in order to fund you to go to conferences, and for this International Experience Awards that I mentioned as a PhD student, if you want to spend some time abroad, and some thesis awards as well. And we also have the ability to organize social and professional events. Typically, those would be proposed by you. So if you were to come here, the students can propose some various social events, and we would be able to fund them. Let's talk a little bit about funding, because I think that's probably something that's important for you as you start thinking about where you want to do your graduate studies. So for students who are admitted into the PhD track, there are different levels of funding possible. There's what we call the gold package, and this is kind of reserved to the very top applicant. And what the gold package provides is it covers the tuition and fees, plus it provides a scholarship or a fellowship of 10,000 euros a year during the master's phase of the program. And then it provides funding for the PhD phase, the full PhD fellowship with a salary of something like 2,000 euros a month for the entire 3 years of the PhD. So that's the gold package, where it's basically full, complete funding for the 5 years, starting from the M1 all the way to the end of the PhD. The silver package basically provides, again, funding for the tuition and fees, and provides the scholarship or the fellowship during the master's phase. And then if the person who has the silver package to go on for the PhD would need to apply for PhD funding. So the funding for PhD at this point wouldn't be guaranteed up front, but of course the student would be able to apply for that funding in order to fund their PhD. And we have various fellowships here on campus. And then there's the bronze package, which basically covers tuition and fees, and doesn't have any additional funding associated with it. For master's students, we're fortunate to have actually biomedical engineering fellowships or scholarships, and we have a fairly large number of these. So for students, who have strong academic backgrounds, we should be able to provide fellowships, and the typical fellowship is 10,000 euros a year. So if you have a strong academic record, and you are interested in it, and you know that you're interested in the PhD, I would strongly urge you to apply to both the PhD track and the master's program. So this is one thing that's important to keep in mind. It's actually pretty much the same application, but you do apply separately to both of those. So if you are interested in the PhD, then you can apply for the PhD track, and then you can apply for the master's. You apply separately, but it's the same. It's the exact same file that you end up uploading. But that way you're considered for both. If you only apply for the master's program, we can't consider you for the PhD track. If you only apply for the PhD track, we can't consider you only for the master's program. So make sure you apply for both if you're interested in both. The other thing that I wanted to just mention is another resource that we have on campus, and this is an interdisciplinary research center that's called Engineering for Health that we launched in 2022. So our E4H, or Engineering for Health Center, is a pretty large structure that groups about 250 people on campus. So this is not just biomedical engineering. This is basically people doing anything related to biological sciences, life sciences, health, bioengineering on campus. So E4H has specific missions. One is to create a community on campus. Again, people, for example, in biomedical engineering, with people in biology, with people, with linked to hospitals, linked to some companies. But so the idea is to create a community on campus of people working on life sciences and health. But the E4H also allows us to recruit new faculty, to recruit new students and postdocs, and to attract visitors from outside. And it also provides funding, it also has a mission to develop collaborations with partnerships with industry and with hospitals and with other academic partners. These are some of the research focus areas in E4H. So some of the colleagues work on digital health, work on modeling of living systems, medical and healthcare devices, imaging and signal analysis, and kind of more basic fundamental life sciences. E4H has an annual forum. For example, this year it was held on November 20th, and there were something like 300 people that signed up to attend the E4H annual forum. So it's our biggest event of the year, where we have all sorts of scientific presentations, student posters, various industry stands. We also have roundtable discussions. So it's a pretty rich event that kind of provides a lot of networking opportunities. But we also organize a number of other events. These are some recent events that we organized in the past year or two. So these are more thematic workshops or symposia. And this would be very important for you, E4H has regular calls for projects. So, for example, Biomedical Engineering Conference scholarships. If you have some research results that you'd like to present at a conference, and you would like to apply for this conference scholarship, the application is pretty easy, and this provides you funding to go and present your work anywhere around the world. Similarly, the design projects, we have funding to if you need to purchase equipment or to purchase materials in order to pursue your design project, various resources of this nature to basically allow you to thrive and realize your dreams, hopefully, in our program. That's pretty much it for the formal presentation. I think what we can do now is open up the floor to questions. I hope the presentation was clear to you. So see, there's one question in the chat. So the question says, let's see. I have a specific interest in clinical engineering and hospital technology management. Are there any opportunities for professional internships with teaching hospitals or healthcare networks that allow students to work on real-world problems related to clinical engineering? So this is Cesar Cruz who asked this question. And the answer is yes. And this can happen at various points in your training here. One is this at the M1 course that I mentioned, where you are in fact embedded in the hospital and you work on innovative solutions to medical problems. So that's one opportunity. Second opportunity is at the level of where you do your master's internship or thesis. That can certainly be done at a hospital or in collaboration with a hospital. And then the PhD can also be done in collaboration with a hospital. And there are number of PhD students who pursue their PhD projects in collaboration with hospitals or in collaboration with companies. So yes, there are ample opportunities to work on real-world problems related to clinical engineering. Hope that answers your question, Cesar.
There is another question. In which school are the courses taking place?
So all the courses happen at the IIP Paris campus in Palaiseau, which is just south of Paris. So most of the courses take place at Ecole Polytechnique. There are some courses at Télécom Paris, and then there's the course at the hospital that I mentioned, the clinical course at the M1 level, which takes place at one of the partner hospitals. But the courses are basically on campus at Ecole Polytechnique and Télécom primarily. Any other?
I have a bachelor in mechanical engineering and a master of science in biomedical engineering. I am basically interested in the PhD track. Can students with master of science still apply for both the master's program and the PhD track?
So you have a bachelor's in mechanical engineering and a master's in biomedical engineering. So there, in that case, if you're applying for a PhD track, you would apply for the M2 program. And so if you're only interested in a PhD at this point, then you wouldn't be applying for, you would not be applying for either the PhD track or the master's program. That is a separate application for just a PhD thesis, right? But if you're interested in getting a master's degree from our program before starting the PhD, then you would apply to the M2 and the PhD track, the biomedical engineering portion of the PhD track. The PhD track is called Bioengineering Quantitative Life Sciences. And then we would consider you at the M2 level. You would do a year of M2, and then you would start with the PhD. Does that help you, Rilwan? I hope that answers the question.
Yeah, I think you answered. There is another question. Is the degree delivered by Ecole Polytechnique or Institut Polytechnique de Paris? Question from
all the graduate degrees, the master's and PhD degrees, are delivered by Institut Polytechnique de Paris.
Yeah. A question from Reliwan. What is the housing and accommodation policy for first-year students?
So we don't have reserved housing per se. There is some on-campus housing that you would need to apply for, but the vast majority of the students actually live around. Like there are many apartments and shared student housing and around campus, and some people live in Paris, and so that's something we can give you some contacts, but it's for you to kind of arrange. So we don't really have reserved student housing for first-year students.
There is a question from Noreen. Can we apply for the master if we have never done physics?
What have you done, Noreen?
Yes.
Like if you're coming, for example, from applied math and haven't done a lot of physics, that would be okay. If you're coming from computer science and haven't done physics and interested, say in data science, that would be okay. But if you've never done any of this stuff, and it kind of depends what your interest is. I mean, if some of the tracks require more physics than others, right? So I'd be happy to answer more specifically if you tell me a little more about your background.
Yeah, for example, for the M2, for the track Biomedical Data Science, okay, you can apply for that track without, if you don't have a background in physics, but you need a strong background in statistics and probabilities and also if you can have a background on computer science. You see, it depends on the, so there is one biomedical engineering master, but we can have different profiles of students. And so a question from Leah. I am studying mathematics and computer science at Paris-Saclay, ACPES, but there is no physics or mechanics in my curriculum. Can I apply?
Yes, you can apply.
Yes.
Again, certain tracks would be more appropriate probably for your background than others. So, for example, the data science, the application of data science track of biomedical data science, that would be appropriate for your background, Leah. I saw there was a question from Cesar about the master's program in biomedical engineering. It's taught entirely in English, and the answer is yes. All the courses are in English.
There is a question from Jan. Can I apply for the M2 program if I am currently in my second year of mechanical engineering at an IP Paris school?
So second year, that means you have you still have the third year, which would be your equivalent to an M1, if I understand correctly. So then you wouldn't be applying to the M2 because you'd still need the third year, which is equivalent to M1, before doing the M2.
A question from Leah. Is there any opportunity for an exchange with an overseas university during the master's? And what about the lab rotations or the internship?
Okay, so during the master's, there is the possibility of getting, for example, during the master's internship or the thesis, some students do that in collaboration with a university abroad. So that can happen. It all depends on the particular circumstances. You asked about the lab rotations. So those are at the M1 level. So those are in our labs. Those are done at IP Paris labs. The goal of the lab rotations the goal of the lab rotations is to basically familiarize you with some of the labs here, so you can start thinking about what labs you're going to do your internship in, as well as your potentially your thesis, your PhD thesis in. So for the lab rotations, we want you to do them in IP Paris labs. For the internship, which is in the second year, there's the possibility of doing something that's maybe joint with another institution. But that kind of depends on the specific topic that you end up deciding to do your internship in.
There is a similar question, quite similar question from Cesar. The research project should be done exclusively at the school or can be external, can be done externally?
So some master's internships, or the master's thesis can be done in companies, or they can be done at hospitals, so they can be external. It all depends on your interests, and it all depends on the specific topic that you're interested in, and whether the topic. What's important is that it has to have a strong research component. I mean, this is intended to be a research internship, so what's very important for us is for it to have a strong, research focus. So, statement of purpose. Basically, what we want to know is what you've done before and where you see yourself going, and why you want to do it at IP Paris. Those are basically the elements that are essential, I think, in your statement. And I'll, Nesma may have something to add to this. But basically, what we want to know is how. I mean, you're telling us a story in a way, right? You're telling us where you're coming from, what you've done already, if you've done some research or some specific projects that because we have your transcripts, right? So we know what courses you took. But the statement of purpose should also be an opportunity for you to tell us a little more about yourself, about maybe your motivation for wanting to study biomedical engineering? Some people, for example, have a very personal reason for wanting to study biomedical engineering, and we would like to hear about that. So we want to know basically why you want to do biomedical engineering, how you've prepared yourself for biomedical engineering, and then where you see yourself going in biomedical engineering. Are you interested in academia? Are you interested in industry? Do you want to do something to save lives? What exactly are you thinking about, and why you think IP Paris is a good place for you?
There is a last question. So, for master's scholarship, is the same as for PhDs, or there are additional steps besides applying?
No, just apply, and then we automatically consider the students for funding for scholarships. So all you need to do is focus on your application and do as good a job as you can on the application, and try to convince us that you're the right person to get one of these scholarships.
There's a question from Ridwan for the PhD track. When we will hear from you? I missed that due to add to the network.
Sylvia, can you?
Yes, I was replying to him into the chat, but it's beginning of April.
So Rilwan, you'll hear back at the beginning of April, and then we'll need you, if you get admitted, we'll need you to decide by around the middle of April whether you're coming or not.
Yes, and last information for the ones of you that need to apply through Mon Master. So the results are in June as usual for Mon Master.
Okay, if there are no other questions, then I hope this was informative. Thank you all for your interest in our program. We look forward to getting your applications. And if you need information, additional information, email us. We will have another informational session in early February. But it'll be pretty similar to what we just presented here. Okay, if there are no other questions, we'll call it a day and have a nice evening. And look forward to reviewing your applications.